let's talk about the Pythagorean Theorem. So the Pythagorean Theorem is named after Pythagoras, who was a Greek mathematician. He lived in the 6th century. So let's jump right in. It states, in a right triangle, the sum of the square of the lengths of the legs is equal to the square of the length of the hypotenuse. So we typically write it as a squared plus b squared equals c squared. A couple important things. This works for a right triangle. How do I know this is a right triangle? Because the corner here is 90 degrees. This little half box tells me that that is 90 degrees. Also important to note, A and B here are interchangeable. It doesn't matter which leg you label as A or B. What is important is that C must be the hypotenuse. The hypotenuse is the longest side of the triangle, and it's the slanted side. So C has to be labeled as the hypotenuse. Super important. So we can use this a squared plus b squared equals c squared to solve for any of the missing sides of a triangle, of a right triangle, when we're given the other two sides. So let's try a couple of examples. So for number 1, the leg is 16, the other leg is 30, and we want to solve for x, which is the hypotenuse. So first, write down the formula. A squared plus b squared equals c squared. Let's go ahead and label 16 as A, 30 as B, and again, those are interchangeable. So I could have written B next to 16 and A next to 30, but we'll just keep it this way. It doesn't matter. But very important that x is our C, our hypotenuse. Now let's substitute into our formula. A is 16, so 16 squared, plus B is 30, so 30 squared, equals C is x, so x squared. Next, you want to calculate what is 16 squared plus 30 squared. So just this left side of my equation. Well, 16 squared is 256. 30 squared is 900. Bring down your equal sign, bring down that x squared. Now let's add these two numbers together. 256 plus 900 is 1,156. Bring down your equal sign, bring down your x squared. So we know x squared equals 1,156, but we want to know what is just x equal. So to find out what x equals, to undo a squared, we take the square root. So take the square root of both sides. On this right side, the square root of x squared is just x. Bring down your equal sign. Then we need to know what is the square root of 1,156. That is 34. So the hypotenuse here in our problem is 34. That is the length. Let's try another one. Okay, number 2. One of our legs is 20. Our hypotenuse is 29. And then we want to solve for x, the missing leg of our right triangle. So again, the long side here, the long slanted side is called the hypotenuse. And then this is a leg, and this is a leg. So if you hear me use those terms, that's what it means. So to start this problem, always write out your formula. A squared plus b squared equals c squared. Let's go over to our triangle. Follow these steps every time. And let's label A, B, and C. Then substitute those values. A is x squared plus b is 20 squared equals c is 29 squared. Don't forget those squareds. X squared plus 20 squared equals 29 squared. All right, so this one's a little bit different as we're solving for a leg instead of the hypotenuse. So let's go ahead and calculate what is 20 squared and what is 29 squared. So x squared plus 20 squared is 400 equals 29 squared equals 841. Now to solve for x squared, solving this equation here, subtract 400 from both sides. X squared equals 441. Again, to solve for x, instead of x squared, last step is always to take the square root of both sides. Square root of x squared is just x, drop the squared. Square root of 441, you can put that in a calculator. That is 21. So the length of this missing leg is 21. So going back, our first problem, that was how to solve for the hypotenuse. You might want to make a note of that. So this problem was solving for the hypotenuse. That slanted side. And then that second problem we did, number 2, is solving for a missing leg. Solving for a missing leg of our triangle. All right, let's talk about one more thing. It's called a Pythagorean triple. A Pythagorean triple is a set of 3 numbers, a, b, and c, that satisfy the equation a squared plus b squared plus c squared. So if we go back, which I know it's getting a little bit messy in our first 2 pages, but the numbers 16, 30, and 34 is a Pythagorean triple. The number 2, the numbers 21, 20, and 29 are a Pythagorean triple. Here are 3 sets of Pythagorean triples that are very common that you should have memorized. So 3, 4, 5 is a Pythagorean triple that's very common. 5, 12, 13, and 8, 15, 17. So you should copy those down. You should have those memorized. They show up quite often. I can use them to solve for other triangles as well. For instance, if I had a right triangle, let's say it's 8 and 6, and I want to solve for x, well, I can notice these numbers are very similar to my 3, 4, 5 right triangle. If I double 3 or times it by 2, I get 6. If I double 4, I get 8. So then I can just double 5, and x is 10. So you can multiply these Pythagorean triplets by the same whole number to find a new set of Pythagorean triples. All right, let's talk about another reason why the Pythagorean triple is important. So the idea of these Pythagorean triples, so for this triangle, it is 16, 30, 34. Do these 3 numbers make up a right triangle? Is this a right triangle? When given the 3 sides and asked, is this a right triangle, we use the Pythagorean theorem. So this is called the converse of the Pythagorean theorem. It states that when we're given three numbers and we do c squared equals a squared plus b squared, which is just how we've been saying the Pythagorean theorem, just flipped. A squared plus b squared equals c squared. If the c squared does indeed equal a squared plus b squared, then those three numbers do indeed make up a right triangle. If, when we test it, and c squared does not equal a squared plus b squared, then we either have an acute triangle or an obtuse triangle. If, when we do c squared, it is greater than a squared plus b squared, that's a greater than sign, then the triangle is not a right triangle, but it is an obtuse triangle. Meaning that one of the angles in the triangle is greater than 90 degrees. If, when we test it, c squared is smaller than a squared plus b squared, then that triangle is an acute triangle. So let's test out a few triangles. And this is something you want to have memorized. A right triangle, c squared equals a squared plus b squared. For an obtuse triangle, c squared is greater than a squared plus b squared. And for acute, it's less than. So is this a right triangle? This 16, 30, and 34 inches, is that a Pythagorean triple? Is this a right triangle? So let's test it. Let's label 16 as A, 30 as B, and 34 as C. It's important that 34 is C. We're deciding, is it the hypotenuse of our right triangle? And it's always the longest side. C will always be the longest side when we label it. So let's test it. Does c squared equal a squared plus b squared? We're going to put a question mark above that equal sign. Is this a true statement? C squared, we're going to write 34 squared. Does that equal 16 squared plus b, which is 30 squared? Oh, sorry, I forgot my squared above my 34. Rookie mistake. So let's try it. So what is 34 squared? 34 squared is 1,156. Let's try the right side. What is 16 squared plus 30 squared? 16 squared is 256. 30 squared is 900. Does that equal 1,156? Yes, 256 plus 900 is indeed 1,156. Check. So yes, to answer that question, this is a right triangle. Let's try one more. Right, so number 2, is this a right triangle? Notice I put a question mark by our right triangle symbol because we have to decide, is this a right triangle? The two legs are 6 and 11, and the possible hypotenuse is 14. So first, let's go ahead and label A, B, C. Remember, is always going to be the largest, the longest side. Let's test it. Does c squared, question mark, equal a squared plus b squared? So let's substitute in these values. C squared is 14 squared. Does that equal my a squared, which is 6 squared, plus 11 squared? So 14 squared is 196. And then 6 squared is 36. And 11 squared is 121. So add these two together and see if it gives me 196. So 36 plus 121 is 157. So these two are not equal. So we put a slash with that equal sign. Those two are not equal. In fact, 196 is greater than 157. So when c squared, which is the left side of my equation, is greater than the right side of my equation, that means that this triangle is not a right triangle. It is an obtuse triangle. And if the left side is less than the right side, then that would be an acute triangle. So those first two examples were how to solve for a missing side with the Pythagorean theorem. And then we talked about, given three sides, can we determine if a triangle is indeed a right triangle or not?